we have to learn the applications of Gauss's theorem. The first application is electric field intensity due to an infinitely long straight wire. So let us consider a uniformly charged wire X, Y. So X, Y be the charged wire. It is charged positively. So the direction of electric field is outward. This is the direction of electric field. And next we have to consider a point P at a distance R from the charged wire. To prove Gauss's theorem, we have to imagine a closed surface. Here we are going to imagine a cylindrical Gaussian surface. So that here this is the cylindrical Gaussian surface. So the length of the Gaussian surface, which is taken as L, this is the length of the Gaussian surface, and the radius of the Gaussian surface is R. Next, we have to consider a smallest portion around the point, that is along the curved surface of the cylinder. Here you just consider this is the elemental area delta S. If we imagine the elemental area on the curved surface, both the electric field and delta S are pointing in the same direction. Therefore, here we have to write the electric flux through the curved surface of the cylinder, which is equal to E into sigma delta S. Here you can just note the value theta is equal to 0, cos 0 is equal to 1. And next, E into sigma delta S represent the curved surface area of a cylinder. The curved surface area of a cylinder is 2 pi R L. And next you have to just consider the smallest portion around the end surface. Here this is the direction of electric field, and here this is the direction of the aerial vector delta S. Both are always perpendicular. If delta S and E is perpendicular, we know that the angle theta is equal to 90 degree. The value of cos 90 is equal to 0. Therefore, the flux through the end surface, which is always equal to 0. The next, the electric flux through the Gaussian surface, which is always equal to the sum of flux through the curved surface and flux through the end face. Flux through the end face is equal to 0. Therefore, the net flux here it is equal to E into 2 pi R L. Can take this is equation number 1. By Gauss's theorem, we know that electric flux phi is equal to Q by epsilon 0. Here we know that it is a straight wire. Therefore, here the charge distribution is represented as lambda is equal to Q by L. We know that lambda represents the linear charge density. So, linear charge density lambda is equal to Q by L. From this equation we can write Q is equal to lambda into L. Therefore, if we substitute the value Q in this equation, we get phi is equal to lambda L by epsilon 0. Can take this is equation number 2. So next you can equate equation 1 and 2. Therefore, from equation 1 and 2 we can write E into 2 pi r L, which is equal to lambda L by epsilon 0. Here this L and L cancel. We get electric field intensity E is equal to lambda by 2 pi epsilon 0 into R. This is the expression used to calculate electric field intensity due to an infinitely long straight.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.